I'm going to tell you about the other news about what we developed. Alex yesterday talked about the classification of websites of companies that we taught, and I'm now talking about another way of speeding up and easing the work of information scientists using our software. I'm talking here, you've seen similar slides already, about the history of the, at the beginning it's called scientific librarians. I'm not talking about how all the things change, because what I think what always stayed the same is they had a lot of domain knowledge to be valuable. They had to have a lot of domain knowledge to be valuable. They knew, in the beginning they knew where to find books in the kind of books that they had. And they knew counterparts in other libraries, so they had this network of libraries where they could order books. They knew how to copy stuff, they knew how to summarize stuff. And this process, which is something that's different today, could take weeks just to get the books. That has changed. The next step, I think, was when these electronic databases came out. You heard that there were CD-ROMs, people selling jukeboxes for a lot of time. And again, now they call themselves information professionals. They still call them information professionals, depending who you ask. These people now had different skill set. They needed to know how to work with these databases. They needed certain IT skills, because at that time, some of the research had to be done on the command prompt on IBM hosts. This got more and more user-friendly, and you needed less and less IT skills. But what stayed the same, you need domain knowledge. If you did not have the domain knowledge, you could not bridge the gap between the technology and the users that were asking you questions. And today, that is all different. Today it's all different, because now you have these huge search engines. You have Yandex in Russia, you have Google in the Western world, you have Baidu in the Asian world, and Bing as a competitor to Google and some others, you all know them. And you have this information consumer who knows how to use this. And they do that themselves. Alex told us yesterday that they, how many people, 25 people a couple of years ago, they cut them down to like 12, and now they are 7, and nobody needs them anymore. Because, I mean, these people know what they are asking for, and they just ask the questions. Bill Gates said, I think it was probably 30 years ago, the information will be at your fingertips. That was what he promised with Windows. We have that now. We have all the information at our fingertips. It's great. And what I think, what people sometimes overlook is, look at what this corporate vice president for business AI at Microsoft said. The future of Bing is going beyond the search box to a personal, pervasive, and predictive experience in which it might not be obvious users are even interacting with the search engine. Consider product search on the HoloLens, in which the users test couches from a product catalog, but look how it looks in their living room, for example. That does not really have much to do with what the information professionals have been doing all their life. This is something that is very consumer focused. And this is exactly what the search engines are learning when they are getting more intelligent. They're learning with the mass of information that users use in their search. And the mass of information that they are getting, that what they're using for their deep learning is, you know that from the first thing that they recognize, cats, right? Because there were so many images of the pets, of the people, and they were, oh, look at my cat. That's how Google learned to recognize cats automatically. And that's this example of how these huge search engines are learning and how they will get more and more consumer focused. They will concentrate on the broad audience and not on what I am searching for as an information scientist. And that is why I think that we still will need information scientists, because what we are searching for here, this is completely different. We are interested in corporate news. That is something you can find on the surface web. We are looking for regulatory documents. That's already a bit more tricky, because you have to identify the right documents that are relevant for your company. And you have to understand which part of that document is interesting for which part of the company. That's already a lot of knowledge. Of course, technology, if you talk about research funding, That's deep web information. You can find that on the surface web. You need to know how to Google and how to get it out of the database of these different publishers of this information. And it goes on and on and on and on, completely different areas, cyber attacks, very, very strong area. And we all heard that we want to do semantic search and stuff. So, do I really want to trust such a deep learning, be it Watson from IBM, or be it some other mechanism from one of the big search engines to find what I'm looking for? I want to make another example there. I bought a fancy car last fall. It can do almost drive itself. Not completely, it's not a Google car, but it can do this automatic cruise control, slowing down and stuff, and has lane assist, so it can steer by itself, and there's an automatic emergency brake assistant that prevents me from bumping into something. And I happen to live in an area where you don't have so many highways. It's in the Black Forest. Streets are very narrow. It's very dark. You have these crash barriers almost in every curve. And the first of these assistance systems that I switched off was the adaptive cruise control. Because whenever I put it to like 90 kilometers an hour, and I drive there, I have a car in front of me, I approach a very narrow curve, the thing loses sight of the car in front of me and speeds up immediately. I have to hit the brake to not crash into the crash barrier. So this does not work. Why does it not work? Because it hasn't been trained in these narrow streets. Same thing I switched off was the lane assist. Streets are so narrow. Whenever a car approaches me, I have to go beyond the right lane, and it tries to bring me back to the road. When I would let the steering wheel loose, I would crash into the upcoming car. So I switched that off as well. I keep switching it on when I go to the highway, but I keep switching it off at home. The next thing I had to switch off was the emergency braking system, because even that does not work. At night, when I come and go there, I drive, I go around a curve that is very steep, and the car is approaching from the other side. The head beams of the other car, it looks exactly in the crash barriers as if it was coming up front towards me. And the system just hits the brake and tries to stop, but there's no danger at all, just for the guy driving in the back of me. So this is what I want to tell you. If the systems are not trained in the situation you want to use them for, better switch them off. They don't work. So if we let the information consumers use Google, we know what happens. We don't have to talk about that, and we talked about this years before. But if we use any of these approaches, are they reliable? Is there in any way a systematic behind it? Is this a structured search, or is it more a random approach of trying to dig into information? Is it repeatable? If I make a decision based on that, is that really a repeatable decision? Is it fast enough? And at the end, if I make a mistake, is that affordable? So I think it's up to the information scientists to make sure that they obtain this information and make it available to decision makers. They can wait, of course, for other technology to be good enough to make that job for them. But for us, in our understanding, is the information scientists again. And that's why now I really call them information scientists, because it's a completely different job. And that what happened in the past, that's what I want to point out. The profile of the librarian being an information professional, now information scientist, changed over time. They had to change their skills because the underlying technology changed. So, you've seen that yesterday, we collect all this data, they decide what the sources are, because they have the domain knowledge, or they could ask their customers, which sources should we tap into? Then you collect them and put them in a, let's call it master search corpus with hundreds of thousands of websites with millions of pages. The next step is, that's what Alex was talking about, we have to make sure that depending on the type of research they have to do in the search corpus, we have to cut it down to only focus on the information we are interested in. That's the part we have learned how to do it automatically. At the same time, we also learned that when we now want to improve search, want to improve the search experience for the end consumers, we have to give them tools like faceted search. But it doesn't make sense to just annotate using a very broad taxonomy to annotate all of the text, because at the end what you're going to end up with is a document where everything is colored in different colors and you don't see more than if you didn't color anything. What you want is that depending on the research field, only the most important terms that are relevant for your audience, for your end consumer, are tagged and emphasized, and that your facetting is following the same approach. That means that you have to do some customization here. And this is, again, this is the job of the people who understand the domain and also understand how the information flows. So this is what we developed for our search people. This is our thesaurus editor. What we do here, this should now be a video. Let us start with this video. So you start designing your own customized thesaurus. In this case, I just made an example, drug-assisted therapy in socially induced conditions. I just made up something. We have the ability to create nodes in our thesaurus on the fly, and all the data that we generate is stored in the background in a triple store, resulting in an RDF that you can export and use anywhere else. I have what we call the reference thesaurus here. In this case, it's the subtree of omega and the subtree of mesh. Any kind of thesaurus or ontology that you have available in RDF format can be used for that. And then you can start dragging concepts from one thesaurus to the other. You see the synonyms here. And you just pull that together how you think you will need it in this certain situation. You can search, of course, for topics. You say, okay, let's search for crime. I'm not interested in only the crime victim, but it's a good term. So let's take the whole subtree, move it over. And now you took the concepts together with all the synonyms and move them in the tree. You see here how the tree evolves. Let's do another search for problems. Family issues could be interesting. Reset the search. You see the whole tree. Let's say, okay, let's just take all the family issues as well. Of course, not all the terms that you want to use, see, the synonyms and the concepts, how they are arranged. Not all the terms that you want to have in your special customized ontology or thesaurus are in a thesaurus where you can pull them. You have other sources where you want to copy the information from to your thesaurus. So in this case, you may know a website where you find dog breeds, because we don't happen to have a thesaurus for dog breeds. So you start with the dog breeds. You do not want to show that label later on in the tagging. So now you go to the website. There are different types of dog breeds. Let's say we start with the pastoral dogs. Copy it over. And take all the type of dogs, copy them, paste them, done. Now they are in our thesaurus, and I can use them for annotation, for facetting, for whatever I want to use it. I do the same thing with all the other ones. I'm not showing all the other ones, just the terriers. Copy, paste. And it's all that's needed to write RDF files. And who has ever seen an RDF file knows you can't read that. It's horrible. So, and this is basically all you need to do to collect all this information. In the background, I kept doing that for a while, because what I want to show next is the real-time tagging. Because you want to see how tagging with this thesaurus would work. So you can add simple sources, either a URL that you type in, or you just paste some text in there where you know the terms that you want to tag should mean. And you have different word types of taggers. We have the tagger that uses the thesaurus that you just created without even saving it. And we also have a part of speech tagger that runs against a dictionary. So when you tag with the thesaurus now, you see all the concepts in the different sources. You can click them and go step by step through the document and see where they were found. And how you arrange the concepts, what is a synonym of what, that's really up to you. What we learned is all the existing public thesauri, like the mesh, is not really useful in search because there are so many layers that if you have to use that for facetting, you have to keep clicking down, go back up, go on again. It just takes time. So for searching, it's good enough to say, okay, I'm interested in heart diseases. So I make a topic heart disease and copy everything what I need flat in there. And then I have like drugs against it. So I have a second one, drug. So you have the different top level concepts in different colors and basically create a thesaurus like we want. And that is the way we thought was really very effective to reduce the amount of work an information scientist needs to do an expert search tremendously. And the end result of this, now we've seen easily fast tagger, part of speech tagger, which words the part of speech tagger thinks are not known. And most of the time the terms that are not in the dictionary are also the terms that are interesting for you to add to your thesaurus if you use a specific kind of text. So the end result of this at the end is then published to the end consumer. And this part is automatic again. So they prepare the data sources, they customize the search corpus depending on the type of request they have, they develop a custom thesaurus for tagging and faceting the search, and here you see the facets. And you see highlighted search, and the terms will be highlighted in the open documents. And we know from the many solutions we have delivered by now, the end consumers, they love this approach. They coming and asking for more like that. So it's not a good idea to wait for some artificial intelligence to solve this problem, because if the Microsoft guy is right, it will all go into the consumer search, making consumer search more intelligent, because there is where Google and the likes make their money. And it will not go to help you information scientists to make their job. But it's also not a good idea to let this opportunity pass, because there are ways to help your end consumers. We all know we cannot rely on Google for doing our searches. But I hear that more and more often still, that people say you do not need information scientists in the field. People should use Google to search. They still don't understand. It's the decision makers who do not really understand that they cannot rely on this. Often this type of information that we search, you cannot buy it. Maybe you cannot buy it because there's a time delay, and it takes 6 weeks until somebody where you got a license from will have this type of information. But maybe we have it on the day because we released to the web. And since we know it's out there, we should see this as an opportunity to do this ourselves and to offer this to our end consumers as a head start against the competition. So again, we have a tremendous amount of information there. We know it's there. We only have a small team, but the small team is enough to manage this information flow. And we have like 3 people at Birmingham who really work on this. And we have about, Alex, how many, 10, 12 productive solutions out there right now? So. And these people are able to manage this, and we are doing more and more every month. So the scales in a way that is, we also and since they're so low maintenance, we can just publish more of these specific solutions. Because this part, again, this part here, and once this is done, this part here, this is all automatic. So, key conclusion, a small knowledgeable team of information scientists can manage a large number of intelligence solutions, and the whole thing without ever talking to the IT people, which usually slows things down. Thank you. That was my part here, and if you have some questions, I'm happy to answer them.